Starting with the last term question then, it says, why is wastewater treated with chlorine in the process of making it potable? Well, we know that we add chlorine to water to make it safe to drink in order to kill bacteria or harmful microorganisms to stop us getting sick. So the answer you need to state is that it kills bacteria. Moving on to the last month question, it says a student carried out a chromatography experiment on 4 inks. State what could be changed in the experiment to make the RF value more accurate. Now, at this point, most students would probably jump to an answer along the lines of using a different ruler or maybe converting into millimeters instead of centimeters, but neither of these changes will actually make the RF value itself more accurate. There are 2 options that we could say for this one. Either use a longer piece of chromatography paper, because that means the dots will probably travel further up the paper and they've got more chance of separating out fully, which makes measuring their distance easier. Or you could use a different type of paper, because, for example, at A-level chemistry, the students will use silica-backed paper, which assists the separation of components during paper chromatography. So you could either use a longer piece of chromatography paper, that's probably the more straightforward answer, or you could use a different piece of paper altogether. Moving on to the last week question, an isotope of carbon has a mass number of 13 and an atomic number of 6. How many of each subatomic particle does it have? Well, if it's got an atomic number of 6, it must have 6 protons. If it's got 6 protons, and it must have 6 electrons, because atoms are neutral, so the positive protons cancel out the negative electrons. And if it has a mass number of 13, I know the number of neutrons is 13 take away 6, so I have 7 neutrons. Finally then, the last lesson question says an element has 3 electron shells with 2 electrons in its outer shell. What is the element? Well, firstly, I know if it's got 3 electron shells in total, it must be in period 3. If it has 2 electrons in its outer shell, it must be in group 2. So I look at the periodic table for the element that's group 2, period 3, and I know that that is magnesium. In this lesson, we're going to look at using the position of an element on the periodic table to predict the charge of an ion. We're then going to use that to draw the structure of an ion, and then we'll link it all together to draw dot and cross diagrams to represent ionic bonds in the formation of ionic compounds. So thinking back to atomic structure then, we know the difference between an atom and an ion is that an ion is an atom with a charge. So an atom with a charge forms an ion. We know atoms are usually neutral overall because of the same number of protons and electrons. So in thinking about how ions are formed then, ions form when atoms either lose or gain electrons. And if we think about it, if an atom gains an electron, we're essentially gaining something negative because electrons have a charge of -1. So if you gain something negative, that makes the ion negatively charged overall. If the atom loses electrons, we're essentially losing something negative, so the ion will have a positive charge overall. In order to become stable, atoms will lose or gain electrons to have a full outer shell. So let's look at some examples to understand exactly what this means. Consider sodium. Sodium has 11 electrons. From electron configuration, I know that 2 can fit in the first shell, 8 can fit in the second shell, and if there was 11, 2 plus 8 is 10, so that leaves 1 left over for the third shell. So the electronic configuration of sodium is 2, 8 and 1, drawn as shown on the diagram. In order for sodium to become stable, it wants this outer shell to be full. There are 2 ways of doing that. It could either gain 7 electrons, so it's full with 8, or it could lose this 1 electron, so this whole shell is lost, so the outer shell then becomes this nice full shell, which gives it that extra stability. And if you think about it, it is much easier for sodium to lose 1 electron than it would be to gain 7, so sodium is going to lose 1 electron when it forms an ion. So if sodium loses 1 electron, it is essentially losing the entirety of this outer shell. So we're going to draw the ion, but this time we're just going to include the first two shells because that third shell has been lost. So this is now the structure of my ion. That outer shell is now full with 8 electrons, so it is stable. And because we've lost an electron, what that means is we've essentially lost a negative particle. And if we lose a negative particle, the charge of the ion becomes positive. A lot of students get really confused why the charge is positive if we are losing something. That's because we are losing an electron, and an electron has a negative charge. If you lose something with a negative charge, then that charge overall becomes positive. So because electrons have a charge of -1, we are losing that negative charge, so the ion therefore has a positive charge. Because we've lost one electron, the ion will have a +1 charge, and to show that, we use square brackets with a +1 outside of the brackets to show that everything in the brackets has this charge. Let's look at magnesium. Using the periodic table, I know that magnesium has 12 electrons in total. Thinking back to electron configuration, I also know that 2 can fit in the first shell, a maximum of 8 can fit in the second shell, and if we started off with 12, I know that leaves 2 electrons to go in the third shell. So the electron configuration of magnesium is 2, 8 and 2. I can double check I've got the right answer by looking at this outer shell. I know magnesium's in group 2, so it should have 2 electrons in the outer shell. I've put 2 there, so I know my answer is correct. In order to become stable, magnesium gains a full outer shell. To do this, it could either gain 6 electrons to fill up the third shell, or it could lose 2 electrons. Hopefully we're starting to realise that it's easier for magnesium to lose 2 than it is for it to gain 6. So magnesium will lose the 2 outer electrons to form an ion. To show the ion using a diagram, remember that we remove the outer shell. So now the electron configuration is simply 2 and then 8. And we know this is much more stable because it's got 8 in the outer shell, which makes that outer shell full. The last thing we need to include is the charge. Well, if I've lost 2 electrons, I'm going to have a positive charge because we've removed 2 negative particles. So I use square brackets to show that the entire ion has a 2+ charge, and it's 2+ because we lost 2 electrons this time. Looking at fluorine then, I know that fluorine has 9 electrons in total. And again, I know that 2 can fit in the first shell, which leaves 7 to go in the outer shell. And that matches up with the group because I know fluorine's in group 7, so it has 7 electrons in the outer shell. In order to become stable, fluorine gains a full outer shell, and again, it can either this time gain 1 electron to make sure there's 8 in the outer shell, or it could lose 7. This time, it will be easier for fluorine to gain an electron. To show an atom gaining an electron, we have to make sure we are showing it coming from another atom. So, if we use crosses to represent the electrons of fluorine, I'm going to need to use a dot to show that fluorine has gained an electron from another atom. And that's why it's called a dot and cross diagram. We use crosses to represent one of the atoms and dots to represent the electrons from the other atom. So in this case, fluorine will gain 1 electron from another atom, and we're going to represent that using this dot here. And that shows the examiner you are aware that these 7 electrons come from fluorine, but this 8th electron, shown by a dot, is coming from another atom instead. The final thing I need to include is the charge. So if fluorine gains 1 electron, it's therefore going to have a negative charge because we've gained a negative particle. So I'm going to put my square brackets in, and it's -1 because we've gained 1. Finally, let's consider oxygen. From the periodic table, I know oxygen has 8 electrons in total. 2 can fit in the first shell and 6 can fit in the outer shell. And that matches up because I know oxygen is in group 6, so it has 6 electrons in the outer shell. Do note, electrons tend to fill shells in pairs. So you'll see when I'm doing my diagrams, all of my electrons pair up around the shell. In order to become stable, oxygen can either gain 2 electrons or lose 6 electrons. This time, it will be easier for oxygen to gain 2 electrons from another atom. So I'm going to need to draw my ion, this time using dots to show the 2 electrons that oxygen receives from a different atom. And as you can see on the right, here are my 2 electrons that have come from a different atom. So you've shown the examiner oxygen has 6 of its own electrons in the outer shell and has received 2 from a different atom. Last thing I need to include is the charge. So I'm going to put my square brackets around the whole ion to show that ion has a negative charge. And this time the charge would be -2. We can also use the periodic table to predict the charge of an ion based on the element's position or group in that table. So for example, if we look at group 1, we know everything in group 1 has 1 electron in its outer shell. Therefore, they're going to lose 1 electron to gain a full outer shell. So everything in group 1 forms an ion with a +1 charge. If we move on to group 2, they've all got 2 electrons in their outer shell. So they will lose 2 to gain a full outer shell. So everything in group 2 forms a +2 ion. If we move on to group 3, they've got 3 electrons in the outer shell. So they will lose 3. So therefore, all group 3 ions have a +3 charge. If I then jump to group 7, they've got 7 electrons in the outer shell. They will gain 1 electron to get a full outer shell. So therefore, everything in group 7 forms a -1 charge. Note, it is not a +7 charge like some people think. It's -1 because they're gaining 1 electron. In group 6, they have 6 electrons in the outer shell. So therefore, they're going to gain 2 electrons to get a full outer shell. If they gain 2 electrons, the ions will have a -2 charge. If you're wondering about group 4, well, we know that they have 4 in the outer shell, so theoretically they could either lose 4 or gain 4. It's just as easy for them to do both. And for that reason, the exam will not ask you about group 4 ions. So you only need to think about group 1, 2, 6 and 7. So, looking at the periodic table, I know chlorine has 17 electrons in total. I know that 2 electrons can go in the first shell, 8 electrons can go in the second shell, which leaves 7 electrons to go in that third outer shell, which matches up because chlorine is in group 7. I also know to make this shell full, we're going to gain an electron from another atom, and I'm going to use a dot to show the examiner that I know that electron is coming from a different atom. So here is my ion. I need to put square brackets to denote the charge, and I need to realise that if I've gained 1 electron, the charge will be -1. And that's because chlorine had 17 protons. It started off with 17 electrons, but it gained 1 from another atom, so it has 18. And if we've got more negative particles than we have positive, there must be overall a negative charge. The reason I've included chlorine is just to introduce us to how we name negative ions as well. So when any ion gains electrons to become a negatively charged ion, the end of that element is replaced with "ide". So for example, chlorine becomes chloride. Likewise, bromine would become bromide, nitrogen would become nitride, iodine would become iodide. So if you look at oxygen, we said before oxygen has 8 electrons in total, 2 in the first shell and 6 in the outer shell. We know that it wants to gain 2 electrons to make this shell full, and we're going to use dots to show that those electrons have came from a different atom. So here is the structure of my ion. And I know if it's gained 2 negative electrons, the charge must be -2. I also know to name the ion of oxygen, the end of the element is replaced by "ide", so oxygen becomes oxide. Pause the video and have a go at drawing the following ions. For each one, I would like to see the electron configuration and the charge. So, hopefully you've been able to have a go at them. So if you look at lithium first, I know lithium has 3 electrons, 2 in the first shell, 1 in the outer shell. It will lose 1 electron to have a full shell, so lithium forms a +1 ion, and the electron configuration looks like this. I know fluorine has 9 electrons in total, 2 in the first shell, 7 in the second shell. Therefore, fluorine is going to gain an electron to get a full outer shell to form an electron configuration of 2, 8. I'm using a dot to show that 8th electron has come from a different atom, and I need to put my charge as -1 because it's gained 1 electron. If we look at calcium, we know calcium has 20 electrons in total with the electron configuration of 2, 8, 8, 2. Therefore, calcium will lose 2 outer electrons to gain a full shell, and if it loses 2 electrons, it will have a charge of 2+. Sulfur, I know, has 16 electrons, so I know goes 2 in the first shell, 8 in the second shell, and 6 in the outer shell. Therefore, sulfur would like to gain 2 electrons. I'm going to use dots to show those electrons coming from a different atom, and that therefore gives sulfur a charge of -2 because it's gained 2 negative particles. I know aluminium's got 13 electrons in total with the electron configuration of 2, 8, 3. I also know that when it forms an ion, it will lose 3 electrons to give a full outer shell, so it just has 2 followed by 8. And if we've lost 3 negative electrons, that gives us a charge of +3. Lastly, we've got nitrogen, which has 7 electrons. It's got 2 in the first shell, 5 in the second shell, but this time we are going to gain 3 electrons to get a full outer shell. If we've gained 3 electrons, nitrogen will form a 3- charge, and like we said, it will form a nitride ion because the ending of that name is replaced by "ide" to represent that it's become a negatively charged ion. So, ionic bonding is the strong electrostatic force of attraction between oppositely charged ions. Now, an electrostatic force of attraction is just the name given to any force between opposite charges. If this occurs between opposite charges, that means there must be a positive ion and a negative ion. So ionic bonding is the strong electrostatic attraction between positive ions and negative ions. I know that metals on the left form positive ions and non-metals on the right of the periodic table form negative ions. So I know ionic bonding occurs between a metal and a non-metal. So that's your test in the exam. If you are given any compound, you need to look at the position of the element on the periodic table. If it's a metal and a non-metal, the bonding has to be ionic. But if you are asked to explain what an ionic bond is, you need to give the definition in the yellow box. So it's the strong electrostatic force of attraction between oppositely charged ions. So for example, if I was to draw my ions for lithium and my ions for fluoride, like we did on the last slide, they would look like this. Lithium forms a positively charged ion, fluoride forms a negatively charged ion. Hopefully we know from Key Stage 3 science that opposite charges attract, and this attraction is called an electrostatic attraction. So the two ions on screen will form an electrostatic attraction which holds them together. This is your ionic bond. It holds the two ions together overall, and it's extremely strong. To draw a dot and cross diagram for an ionic bond, all you need to do is draw both ions like you've just done on the last slide, but this time you're doing 2 for each one. So if I go through an example, we've got sodium chloride, aka salt. So just like we've done before, I'm going to draw the electron configuration out of sodium, which is 281. I know to get a full shell, sodium will lose this one electron and form an ion with a +1 charge. So there's my sodium ion. Likewise, I know chlorine's got 17 electrons, 7 in the outer shell, but it wants 8, so we're going to gain an electron. Well, if you think about it, sodium is trying to get rid of an electron and chlorine is trying to gain an electron. So where do you think chlorine is going to gain this electron from? Hopefully you're able to see that it comes from the sodium. So the electron we've just removed from the outer shell of sodium has now been transferred to chlorine. And we can see that clearly because in our diagram we've used dots to show the electrons of chlorine and crosses to show the electrons of sodium. So here we're showing the examiner that that electron has came from the sodium ion. These ions then attract, because we know opposites attract, and form what we call an ionic bond. So to draw the dot and cross diagram for an ionic bond, all you have to do is draw the ions of 2 atoms. So it's the exact same process, but we're just drawing 2 ions this time. There is a shortcut, so you don't need to draw the full electron configuration because you're having to draw 2 ions. So instead, you can just draw the outer shell electrons if you want. So instead of drawing the inner shell electrons, you could have just drawn it like this. And that's because it's only the outer shell of electrons that take part in bonding. So it's only these electrons that are actually involved. You won't lose any marks if you draw the inner shells, but you can just draw the outer shells instead. So let's look at calcium oxide then. Calcium has 20 electrons, 2, 8, 8, 2, and it will lose the outer 2 electrons to form a full shell. If it loses 2 electrons, this gives it a charge of +2. Oxygen has 6 electrons in the outer shell, so it's going to gain 2 electrons. And hopefully you can realise oxygen's looking to gain 2 and calcium is looking to lose 2. So the 2 electrons for oxygen will come from the calcium. And we're showing that using these crosses here. So you're showing the examiner, you know that oxygen has gained 2 electrons from this calcium, which leaves calcium with a +2 charge and oxygen with a -2 charge. These 2 ions attract because they're oppositely charged to create a strong ionic bond. That is your dot and cross diagram for calcium oxide. There are 2 more examples I want to go through, and then I'll give you some to try yourselves on the mini whiteboards. So the first is calcium chloride, which is CaCl2. Next lesson, we're going to look at building ionic formulae, but for now, we just need to be able to draw dot and cross diagrams for CaCl2 and Na2O, sodium oxide. So from the last slide, we know calcium has 2 in the outer shell, loses those 2 electrons to get a full outer shell, and forms a +2 charge. We also know chlorine has 7 in the outer shell, so it's going to gain 1 electron. This time it'll take it from the calcium, and we can see that because we've got the cross. Now the problem here is Calcium wants to lose 2, but chlorine only wants to gain 1 electron to get a full outer shell. Chlorine will not take 2 electrons from calcium. Therefore, we need a second chloride ion because calcium wants to get rid of both electrons. So you could either draw this out again, or to save your time, just put a big 2 in front of it so you know that calcium needs to get rid of 2 electrons, chlorine needs to gain 1, so I need 2 chloride ions, each to gain 1 electron, so they're gaining 2 in total from the calcium. Likewise, with sodium oxide, sodium is in group 1, so it wants to lose 1 electron to form a +1 ion. But oxygen is in group 6, so it needs to gain 2 electrons. Sodium will not give oxygen 2 electrons because that will make it less stable. So instead, I'm going to need 2 lots of the sodium ion. Each sodium will give 1 electron to oxygen, so oxygen gets 2 in total. 1 from this sodium and another from the other sodium. And again, we've shown this using our 2 crosses to show that the 2 sodiums have both donated 1 electron. So this is as hard and as difficult as dot and cross diagrams will get for ionic compounds. But on the next slide, we'll go through some examples to practice. Pause the slides and have a go at drawing ionic dot and cross diagrams for the following ionic compounds. Okay, hopefully you've been able to get answers that resemble the ones on the board. So potassium, group 1, so forms a +1 ion. Chloride, group 7, so forms a -1 ion. Potassium's trying to lose 1, chlorine's trying to gain 1, so I only need 1 of each to form my dot and cross diagram. Lithium's in group 1, so forms a +1 ion and will lose 1 electron. But oxygen is in group 6, so I'll form a 2- ion to gain 2 electrons. Therefore, I need 2 lithiums, each lithium given 1 electron to make sure oxygen has a full outer shell. It's a very similar situation with calcium fluoride. Calcium's in group 2, so it loses 2 electrons, but fluorine is in group 7, so it gains 1 electron. Therefore, I need 2 lots of the fluoride ion. Each one is going to gain 1 from calcium to make sure calcium has a full outer shell, and 2 fluoride ions have a full outer shell as well. The tricky example is the aluminium oxide. So aluminium is in group 3, so it has 3 electrons in the outer shell. That means aluminium will lose 3 electrons to form an ion with a +3 charge. But oxygen, as you can see from the example above, only wants to gain 2 electrons. So therefore, oxygen is not going to gain 3, but aluminium wants to lose 3. So we need to manipulate the numbers to make sure that aluminium has a full shell and oxygen has a full outer shell. To do this, we need to think about the common multiple factors of 2 and 3. Well, I know the lowest common multiple is 6. So I need 2 lots of the 3 plus aluminium to make it into +6. And I need 3 lots of the oxide ion to make that into -6. So that means 2 aluminiums lose 3 electrons, so 6 electrons are lost in total. 3 oxide ions gain 2 electrons, so 6 electrons are gained in total. They balance out, and now they have a full outer shell. If you struggled with this last one, we are going to look at building ionic formulae in the next lesson, which will help you determine that we need 2 aluminium ions and 3 oxide ions.